this is the homework 4.8 practice. On Monday nights, Papa Pizza offers a special 2-for-1 deal on its medium 2-topping pizzas. All pizzas come with sauce and cheese. The customer can choose any 2 of their 25 toppings to complete the order. How many different pizza toppings, possible pizzas are there, assuming that the customer chooses exactly 2 different toppings? Okay, not the same, but 2 different toppings. And now, we have to first answer, does the order matter or not? Does it matter if pepperoni gets put on first and then bacon on top of that? No. 2 toppings are 2 toppings. So that's why it's a combination. There are 25 toppings and we're choosing 2 of them. Okay, so if you go to Desmos and figure out 25, choose 2, comes out to be 300 different pizzas that you could get. Okay. Okay, so the next question. At the end of a week-long seminar, the presenter decides to give away signed copies of his book to 4 randomly selected people in the audience. Once one person gets it, they're not going to get a second copy, so there's no order to it. As long as you're one of those 4, you win, right? So how many different ways can this be done? So there are 30 people, and we're choosing 4 people for the book. Okay, so go to Desmos. 30 choose 4 gives you 27,405 different ways of people getting those books. Okay, almost everyone has a drawer that holds miscellaneous batteries of all sizes. Suppose your drawer contains 8 AAA batteries, but only 6 of them are good. You have to choose 4 for your graphing calculator. If you randomly select 4 batteries, what's the probability that all 4 will be good, will work? Okay, so we think about this. We want the probability of choosing a good battery, 4 good batteries, over the probability of all possible ways of choosing 4. Okay, so of choosing 4 good batteries. Okay, there's a total of 6 good batteries, and I need to choose 4 of them. So if I figure that out, there are 15 different ways that I could get 4 good batteries. Okay, now how many different ways total can I get those batteries? Okay, there's a total of 8 batteries there, and I'm choosing 4 of them. So how many different combinations of 4 could I get? Okay, so if there's 8 and I'm choosing 4, there's 70 different ways. Okay, if I divide those, I get 21%. Okay, so there's a 21% chance that out of those 8 batteries and 6 of them being good, that I get 4 that will work at one time. Okay, at a local high school, 95 students have permission to park on campus. Don't have much parking. Each month, the student council holds a golden ticket parking lottery. The 3 lucky winners are given reserved parking spots next to the main entrance. Last month, the winning tickets were drawn by a student council member who was in the statistics class. When all 3 tickets went to the same class that person is in, they said it was rigged. There were 28 students in the class, all of whom were eligible to park on campus. Okay, so we want the probability of picking 3 people of the 28 in the class. How many different ways can I pick that? So that would be, there's 28 people and I'm picking 3 of them. So how many, the total number of ways I can pick 3 people from the class, divided by the probability of picking 3 people out of everyone in the whole school, out of all 95. So that would be 95, and I'm choosing 3 people. Okay, so that's the probability of getting a group of 3. How many groups of 3 there are in the class, out of how many groups of 3 there are in the whole school. So if I work that out, it's 28, and I am choosing 3. There are this many different possible groups of 3 in the class, And in the whole school, there's this many groups of 3 in the whole class. So if I divide those, I get 0.024. So there's a little over a 2% chance that all 3 tickets would come from the same class. Raises some suspicion, maybe possibly that it was rigged. Okay, next, last one here. A certain basketball team has 12 players. 5 of them are guards, and 7 of them are forwards or centers. If the coach wants to choose 5 starters at random by choosing names out of a hat, how many possible groups of 5 could there be? Okay, so there are a total of 12 people. Doesn't matter the order of which they're choosing. Okay, we're just choosing 5 of them to start. Doesn't matter if you're the 1st, 2nd, 3rd, 4th, 5th, right? So it's combinations. If I choose 12, how many different ways are there? 5. Okay, so part A, it's going to be 792 different starting teams that could happen. Okay, part B. To avoid an unbalanced lineup, the coach wants to choose 2 guards and 3 forward centers. To do this, they play the 5 people into the hat that are guards, and they choose 2 of them. And they put the 7 forward centers into a hat and choose 3 of them. Okay. So for the first event, there are 5 guards, and we're choosing 2 of them. So 5, choose 2. There's 10 different ways we could do this. And then the center forwards, there were 7, and I'm choosing 3. And there's 35 different ways of doing this. So by our counting principle, we know that if I'm going to do this and this, I'm going to multiply this together. So there's 350 different combinations of getting 2 guards and 3 forwards on a team. Okay, so that's overall. If they're positionless, just randomly picking people. This is if we break them into groups first. Okay, part C. The coach chooses her 5 starters at random by drawing names out of a hat. Find the probability that she selects an ideal lineup with 2 guards and 3 forwards, centers. Okay, so we want the probability of 2 guards and 3 centers out of the total number of things. Okay, so we found out there's a total of 792 different combinations of starters they could have, and 350 of those had 2 guards and 3 forward centers on it. So if you divide that, you get 44%. So 44% of the time, if I just choose a random 5, I will have 2 guards and 3 forward centers.